For a few tense weeks in 2025, headlines everywhere were asking the same terrifying question. Was an interstellar comet about to slam directly into Mars? Videos spread claiming James Webb had confirmed a collision course. Forums lit up with predictions of a fiery impact visible from Earth. Some claimed NASA was quietly preparing for the worst. It was one of the most viral space stories of the year, and now that the dust has genuinely settled, we can finally tell you exactly what happened using the real, confirmed data, because the true story is honestly just as compelling as the panic was, minus the parts that were never actually true. Let's rewind to where this all started. 3I Atlas, the object at the center of this entire saga, was first spotted on July 1st, 2025 by the NASA-funded Atlas survey, the Asteroid Terrestrial Impact Last Alert System, operating out of Rio Hurtado, Chile. Within days, astronomers calculated its trajectory and found something immediately significant. This object wasn't orbiting our sun, it was moving on a hyperbolic path, meaning it originated from another star system entirely and would pass through our solar system. Exactly once on a one-way journey before disappearing back into interstellar space forever. That made it only the third confirmed interstellar object in history, following Oumuamua in 2017 and Borisov in 2019. From the moment its trajectory was mapped, scientists knew 3I Atlas would pass reasonably close to Mars during its journey through the inner solar system. That's not unusual on its own. Plenty of comets and asteroids pass near planets without incident. But because this was only the third interstellar object ever tracked, and because early orbital calculations always carry a margin of uncertainty that narrows as more observations come in, that reasonably close distance became the seed of a story that spiraled fast, especially once some corners of the internet ran with early, unrefined trajectory estimates and skipped straight past the uncertainty to the word collision. Here's what was actually happening scientifically during that window. As 3I Atlas approached the inner solar system through the late summer and early fall of 2025, researchers using the James Webb Space Telescope were tracking its composition and behavior closely, and genuinely found something worth reporting: an unusually carbon dioxide-rich coma, unlike the water-dominated activity seen in most solar system comets. That's a real confirmed finding, one we'll dig into properly later in this video. But composition data about what a comet is made of is a completely different thing from trajectory data about where it's actually headed, and in the rush to cover this story, those two entirely separate categories of information got blended together in a lot of the coverage that went viral at the time. The real trajectory data, refined continuously by NASA, ESA, and independent observatories throughout September 2025, told a consistent and, frankly, far less apocalyptic story. 3I Atlas was headed for a close approach to Mars, not an impact. As tracking precision improved week over week, the predicted flyby distance actually stabilized rather than closing in dangerously, settling at approximately 18.6 million miles, or roughly 0.2 astronomical units. For comparison, that's about 78 times the distance between the Earth and the Moon. Close enough, on a cosmic scale, to be a genuinely exciting scientific opportunity. Nowhere close enough to be any kind of impact threat. That close approach actually happened in real time on October 3rd, 2025. And instead of the catastrophe some corners of the internet were predicting, it became one of the more remarkable moments of coordinated science in recent memory. Spacecraft already stationed at Mars, including ESA's Mars Express and Trace Gas Orbiter, neither of which was originally designed to study comets, had their instruments repurposed on short notice to observe the flyby directly. For the first time in history, humanity had functioning spacecraft already in position to watch an interstellar object pass near another planet up close, capturing data that Earth-based telescopes alone never could have provided. Let's get into what the Mars flyby actually revealed. Because once the panic died down, this turned into one of the most genuinely productive observation windows in the entire 3I Atlas story. When 3I Atlas swept past Mars on October 3rd, 2025, at a distance of roughly 18.6 million miles, it gave researchers something unprecedented: a second independent vantage point on an interstellar object, from spacecraft already stationed at another planet. ESA's Mars Express and Trace Gas Orbiter, both originally built for entirely different missions studying Mars' own atmosphere and surface, had their cameras and spectrometers redirected on relatively short notice. Neither spacecraft was designed to chase comets, and getting usable data required real engineering improvisation from mission teams working against a tight window. But it worked, and the resulting observations became a genuine cross-check against everything Earth-based and Earth-orbiting telescopes were finding from much farther away. The cross-checking mattered enormously because it's exactly the kind of independent verification that turns a single dramatic claim into confirmed science. Around the same period, James Webb's own observations, gathered starting in August 2025, had already revealed something genuinely unusual about 3I Atlas's composition. Nearly every comet studied in detail before this one, including Borisov, runs primarily on water. Sunlight hits an icy nucleus, water sublimates, and that process drives the visible coma and tail. 3I Dart Atlas broke that pattern entirely. Webb's measurements showed a coma overwhelmingly dominated by carbon dioxide rather than water, with a ratio dramatically higher than anything recorded in a solar system comet at a comparable distance from the Sun. That finding is worth sitting with, because it's the real reason 3I Atlas became such a major story in the scientific community well before any Mars collision rumors started circulating. An object with this much CO2 relative to water almost certainly formed in a very different kind of environment than the one that built our own. Solar system's comets, a place where water ice was either scarce from the start or had already been stripped away. That's a legitimate, peer-reviewed finding, and it's a much stranger and more scientifically interesting story than a fabricated collision, precisely because it points toward an object built from an entirely different chemical rulebook than anything native to our neighborhood. Then, in December 2025, well after the Mars flyby, Webb delivered a second confirmed result, a robust, unambiguous detection of methane in the coma. That's genuinely rare to confirm this cleanly in cometary spectroscopy, and it strengthens the picture of an object with a distinct carbon-rich chemical inventory, adding another layer to what researchers now understand about where and how this comet likely formed. So here's an important thing to be clear about, because it directly explains how the collision rumor got started in the first place. Around the same period, Webb was releasing these composition findings. Some outlets and online creators noticed that 3I Atlas's trajectory was being refined and adjusted, as it always is with newly discovered objects, and that its coma's unusual CO2 output was affecting its outgassing behavior in ways that made precise position predictions. Slightly more complex than for a typical water-driven comet. That's a real technical detail. Comets propelled by asymmetric outgassing jets, especially unusual ones like CO2-dominated jets, can experience small, measurable deviations from a purely gravity-driven path known as non-gravitational acceleration. Scientists track and account for this routinely. It's a well-understood part of orbital mechanics for active comets. But in the hands of less careful reporting, the comet's path required ongoing refinement due to unusual outgassing, got compressed into something much more dramatic. The comet's path keeps shifting toward Mars, and scientists don't know why. That's simply not how the actual trajectory data played out. Refined tracking through September and October 2025 showed a consistent, stable flyby distance of roughly 18.6 million miles, not a closing gap. NASA, ESA, and independent observatories all converged on essentially the same prediction well before. The actual flyby occurred, and that prediction held. There was no last-minute surprise, no dramatic redirection, and no scenario in the confirmed data where impact was ever a realistic outcome once precise tracking was established. What the Mars flyby did give researchers, beyond the composition confirmation, was a genuine once-in-a-generation observational opportunity. Having spacecraft already positioned at Mars meant scientists could study 3I Atlas's dust environment and outgassing behavior from an angle and distance, completely different from anything achievable with Earth-based instruments, adding real depth to the picture Webb, Hubble, and the Very Large Telescope in Chile were separately building. It's genuinely one of the more remarkable examples of improvised, cross-agency scientific coordination in recent memory, precisely because it happened without any of the manufactured urgency the collision rumors implied. It happened because researchers recognized a rare opportunity and moved quickly to use existing hardware in a new way. So by the time 3I Atlas moved on from Mars and continued toward its solar perihelion later that October, the real story wasn't did it hit, because that was never seriously in question once precise tracking was established. The real story was what an unprecedented, multi-vantage point observation campaign had revealed about an object that might be older than our own sun. In the next section, we're going to cover what happened next as 3I Atlas approached the sun directly, and address honestly what the actual risk assessment looked like from the researchers who were tracking it in real time, rather than the version that spread across social media. Let's talk about what happened next, because after the Mars flyby, 3I Atlas headed straight into the most physically dangerous phase of its entire journey, and this part of the story didn't need any exaggeration either. On October 29th, 2025, 3I Atlas reached perihelion, its closest approach to the Sun, at a distance of roughly 203 million kilometers. That's actually a fairly distant perihelion compared to many well-known comets, but it was still close enough to raise a real legitimate concern among researchers. And this is worth being clear about, because it's a genuine risk that had nothing to do with any collision rumor. The concern wasn't that 3I Atlas might hit something, it was that the heat and radiation from a close solar pass might cause the nucleus to fracture or disintegrate entirely. something that has happened to other comets making similar approaches, including, notably, 2I Borisov, the second interstellar object ever confirmed, which showed signs of fragmentation as it neared the Sun back in 2019. That comparison mattered a lot to researchers heading into 3I Atlas's own perihelion. If the second interstellar object we ever studied broke apart under solar heating, there was a real, scientifically grounded reason to wonder whether the third might do the same. And for a stretch of about 2 weeks surrounding perihelion, 3I Atlas actually became unobservable from Earth entirely, passing behind the Sun's glare, completely out of view of every ground-based and space-based telescope tracking it. That created a genuine, if very different, kind of tension than the Mars collision story. Researchers spent that blackout window not knowing whether the object they'd spent months studying would still be intact when it finally came back into view. When tracking resumed in early November 2025, the answer came back clear. 3I Atlas had survived the solar passage fully intact. It emerged still active, still outgassing, continuing its outbound trajectory exactly as gravitational physics predicted. That survival, on its own, became a genuinely important scientific data point, because it told researchers something meaningful about the structural durability of material from another star system. An object, potentially, billions of years old, having drifted through interstellar space for the vast majority of its existence, proved tough enough to with a star without breaking apart. That's not a small thing to confirm. Now, let's address something directly, because it's an important part of separating real scientific caution from manufactured panic. Researchers tracking 3I Atlas throughout 2025 were never operating under the assumption of a Mars collision, but they were absolutely taking the object's uncertainty seriously, in the appropriate, professional way that real orbital mechanics demands. Every newly discovered comet, especially an interstellar one with no historical tracking data to compare against, starts with a wider range of possible trajectories that narrows as more observations accumulate. That's just how orbital determination works. And it's exactly why early trajectory estimates for any new object, including 3I Atlas, carried genuine uncertainty in the days and weeks immediately following its July 1st discovery. As more data came in through August and September, that uncertainty narrowed dramatically, and by the time the actual Mars flyby distance was confirmed at roughly 18.6 million miles, that number had been independently verified by multiple observatories using different methods, giving researchers real confidence in the prediction well before the flyby itself occurred. This is also a good moment to address why interstellar comets specifically tend to generate this kind of viral speculation more than typical solar system objects. Unlike comets we've tracked for decades or centuries, interstellar visitors arrive with zero historical baseline. We have no prior observations of their orbit, no established pattern of past behavior, and often only weeks of data before major encounters happen. That genuine scientific uncertainty, appropriately communicated by researchers as a range of probabilities that narrows over time, is an easy target for sensationalized reporting that strips out the nuances and jumps straight to worst-case framing. It happened with Oumuamua's unexplained acceleration in 2017, and it happened again here with early trajectory. Refinement getting recast as an active, ongoing collision threat, rather than the normal expected process of narrowing down where a genuinely new kind of object is actually headed. By March 2026, with the drama of both the Mars flyby and the solar perihelion well behind it, 3I Atlas was tracked passing near Jupiter's orbital distance, continuing its outbound journey back toward interstellar space. Fainter now, but still trackable by major observatories. At no point in that entire timeline, from discovery in July 2025 through its confirmed post-perihelion survival, did the actual tracking data ever support a Mars impact scenario. What it did support, consistently and repeatedly, was a rare, safe, and genuinely valuable scientific opportunity. A chance to study an ancient interstellar visitor up close, from multiple vantage points, using instruments never designed for this exact purpose, repurposed on short notice because researchers recognized how rare and how limited this observational window really was. In the final section, we're going to bring this all together, look at where 3I Atlas actually stands right now as of mid-2026, and talk honestly about what this entire episode, rumor and reality both, actually teaches us about how quickly real scientific uncertainty can get turned into something far more dramatic than the data ever supported. So let's bring this all together, because after nearly a year of tracking, 2 major encounters and 1 viral collision rumor that never matched the actual data, we can finally give you the complete, accurate picture of what really happened with 3I Atlas and Mars. Here's the confirmed timeline, start to finish. 3I Atlas was discovered on July 1st, 2025, by the NASA-funded Atlas survey in Chile, immediately identified as only the 3rd confirmed interstellar object in history. Its trajectory, refined continuously through the following months, showed a close approach to Mars, stabilizing at roughly 18.6 million miles, a safe, non-threatening distance that multiple independent observatories confirmed well ahead of time. That flyby happened exactly as predicted on October 3rd, 2025, giving ESA's Mars Express and Trace Gas Orbiter a genuine improvised opportunity to observe an interstellar object up close for the first time in history. There was no impact, no near catastrophe, and no last-minute course change. The prediction held because the science behind it was sound from the start. What was real, and what actually drove the scientific significance of this entire episode, was everything happening around that flyby rather than any manufactured collision threat. James Webb's observations, beginning in August 2025 and continuing through December, confirmed a coma dominated by carbon dioxide, rather than water, along with a later, robust methane detection, both pointing toward an object built from a chemical inventory genuinely different from anything native to our own solar system. The object then survived a full close pass by the Sun on October 29, 2025, emerging intact in early November. After a tense 2-week stretch where it was completely unobservable from Earth, hidden behind solar glare with researchers genuinely uncertain whether it would hold together the way its predecessor, Borisov, ultimately did not. Taken together, that's a genuinely remarkable scientific story on its own merits. An ancient interstellar traveler, chemically unlike anything we'd studied before, survived both a close planetary flyby and a direct solar encounter, all while multiple space agencies coordinated in real time to capture as much data as possible before the object disappeared for good. That's the actual headline the story deserved from the beginning, and it never needed a fabricated collision to be worth your attention. So why did the collision rumors spread as fast and as far as it did? Partly because of genuine, appropriately communicated scientific uncertainty in the earliest days of tracking, the kind that exists for every newly discovered object, and narrows naturally as more data comes in. Partly because of the real technical complexity of predicting the path of a comet with unusual CO2-dominated outgassing, a legitimate detail that got stripped of its nuance in less careful coverage, and partly because interstellar objects, precisely because they're so rare and so unprecedented, tend to attract exactly this kind of speculation the same way Oumuamua's unexplained acceleration did back in 2017. When you combine real scientific uncertainty with an audience primed for dramatic space headlines, a technical footnote about trajectory refinement can turn into a collision course remarkably fast, even when the underlying data never supported it. As for where 3i Atlas actually is right now, based on the most recent tracking data through mid-2026, the comet passed near Jupiter's orbital distance earlier this year and continues fading as it moves farther from the Sun, back out toward interstellar space on its one-way journey. Researchers expect it to remain faintly observable to the largest space telescopes for at least another year or two, with some projections suggesting Hubble and Webb could still catch it as late as 2027 before it becomes too distant and too faint to track at all. After that, it's gone permanently, carrying whatever chemical secrets it hasn't already given up, continuing a journey that will likely take it past countless other stars over the coming millions of years, with no return trip and no future encounter with anything or anyone we'll ever know about. There's a real worthwhile lesson in this whole episode, and it has nothing to do with Mars almost getting destroyed. It's about how quickly legitimate scientific uncertainty, the normal expected kind that exists at the start of studying any genuinely new object, can get transformed into something far more dramatic than the evidence ever supported, especially when the story involves words like interstellar and collision course together. The actual science here, an ancient, chemically unusual visitor, surviving both a planetary flyby and a solar encounter while multiple space agencies raced. To study it in real time was already a genuinely great story. It just happened to be a true one, which turned out to matter less to the algorithm than the version that wasn't. So here's the question worth actually sitting with, grounded in what genuinely happened rather than what went viral. Now that we've seen how fast a legitimate trajectory refinement story can turn into a fabricated collision panic, how much of what you're hearing about the next interstellar object, whenever it's discovered, do you think you'll be able to trust at face value? If this breakdown helped you separate what actually happened with 3i, Atlas, and Mars from what was just viral speculation, hit that like button, subscribe if you're new here, and drop a comment on whether you remember seeing the original collision claims when they were spreading. Because as detection technology keeps improving and we start finding these objects more often, this almost certainly won't be the last time a real scientific story gets turned into something it never was.